All right, guys. So now we'll move on to the final part of the lesson in chapter one. So identities and equations. Okay, so you can find and use identities to, for the hyperbolic functions that are similar to the trigonometric identities. You can solve equations using hyperbolic functions. Okay, guys. So we are basically learning how to work with now you worked with trigonometric identities previously in the past, right? So now we are going to learn how to use hyperbolic identities. Okay, and we are going to compare the differences and similarities between trigonometric and hyperbolic. Okay, so here they ask you in this case, okay, prove that cos square a minus sine square a is identical to 1. Okay, now if you kind of look at this and you can maybe recall the kind of like the close by trigonometric function, right? So do you recall that in trigonometric functions we had sine square plus cos square equal 1, right? Or cos square plus sine square equal to 1. But you can see here in the hyperbolic, now the identity they've given here is slightly different, right? So it's cos square a minus sine square equal 1. Okay, so let's see why this is happening and if this is really true, and let's see how to build a relationship between trigonometric and hyperbolic. Okay. Okay, first thing is let's quickly do this proof, right? So what they've done over here. So we are going to show that cos square a minus sine square a is equal to 1. I'm just going to do the same proof and explain you every step in the middle. Okay. Okay, so we already know the definitions of cosec and sine, right, guys? So that was the very beginning of this lesson, the all the definitions. Okay, so then what was the definition of cos A? Cos x was ex plus e to the power minus x divided by 2, right, guys? So here it's cos A. It's going to be e to the power a plus e to the power minus a divided by 2. So this is actually cos a, but we are supposed to work with cos square a. So you're supposed to square this entire function, right? So you multiply this with itself, or you can just put a bracket and put a square. All right, guys. So this is cos square a and then minus sine square a. So sine square is going to be e to the power a minus e to the power minus a, right, guys? Divide by 2. This is sine A and you're supposed to again square it. All right, guys. So this is the this is the substitution of the values to cos square A minus sine square A. So now let's simplify and see if this actually is becoming identical to 1. Okay, so it's a matter of expanding brackets. So here we have EA plus e to the power negative A square divide by the square of 2 is 4, right, guys? Because here you square the numerator as well as the denominator. Then here you have minus e to the power a minus e to the power minus a, the whole thing squared, divide by 2 squared, that's a 4. Right, guys? Do you agree? Okay, so now you need to expand this bracket. So how does it expand? Uh, shall I directly work on it? So e to the power a, you're going to square it. So it's going to be e to the power 2a plus 2 times e to the power a, e to the power minus a, plus the square of e to the power minus a is e to the power minus 2, right, guys? I just immediately expanded the bracket, okay? Minus here you get e to the power 2a minus 2 e to the power e to the power a, e to the power negative a, right, guys? And then plus e to the power negative 2a. This is just expanding the bracket, right, guys? So I think these are pretty simple things, right? You square each term and you take twice the product of these two, right? And then I think we can simplify this a little bit further because you can see e to the power a when you times it by e to the power negative a, the power that, and you get e to the power 0, right? All right, so this is going to be e to the power 0 and e to the power 0, which leads to 1. All right, guys, same over here, e to the power a, e to the power negative a is e to the power 0, which leads to 1. Okay, so then you get here e to the power 2a plus 2 plus e to the power negative 2a divided by 4. Minus over here, you get e to the power 2a minus 2, then plus e to the power negative 2a divide by 4. All right, guys. So now we've opened the brackets, we've simplified. So now it's time to combine the fractions together, right? So we have a common denominator 4. So let's expand them together. So you have e to the power 2a plus 2 plus e to the power negative 2a. When you expand the bracket with the negative sign, you get here negative e to the power 2a. Negative, negative, that's a positive 2. And then minus negative into positive, that's negative e to the power negative 2a. Divide by 4. You can see now certain terms are gonna cancel out, right, guys? So you can see e to the power positive 2a and here minus e to the power 2a. So they cancel out, right, guys? And then you can see e to the power negative 2a and minus e to the power negative 2a, they cancel out, right? Because you have plus 1 here of this guy and you have a negative 1 of the same guy. So equal quantities and they cancel out. So you can see you're remaining with 2 plus 2, that's 4 divided by 4. So 4 divided by 4, that's 1. All right, guys. So this is the show that, and we got the answer. So we showed in the hyperbolic function, you have to go with cos square a minus sine square a is identical to 1. So you're not going to be using the exact same typical trigonometric equation, right? In trigonometric, it was cos plus sine, cos square plus sine square equal to 1. But the hyperbolic equations are slightly different. So you can see here, it's not that. You have to use a negative sign here. Okay, guys? Just be with me for a moment and I'll tell you how the relationship actually works. Okay. All right, guys. So we'll go move to one more sum. Okay, a proof. So this guy. So you can see here cos 2a. So we're going to do the proof of cos 2a. They want to show you that cos 2a is equivalent to 1 plus 2 sine square a. So guys, if you recall the equation of trigonometric, so I think you might have seen something a little bit similar, right, in trigonometric, but maybe not exactly the same. So if you recall the double angle formula, what was it? So do you recall this from P3? So it's going to be cos 2a equals, do you recall? 1 minus 2 sine square a, right, guys? Do you recall? This was the original trigonometric function, right? So now you can see when it becomes hyperbolic, it looks mostly similar, but there are some differences, right? Especially with the sign. I think we noticed that over here as well, right? The signs are different. So we will be learning about this rule in a moment, okay? So before that, let's just do the proof for now. So we are going to show that cos 2a is actually identical to 1 plus 2 sine square. Okay, so let's work on this. Let's work on the proof. All right, guys. Okay, so what do we know of 1 plus 2 sine square a? So 1 plus 2, we know sine a is e to the power a minus e to the power minus a, divide by 2, and you're supposed to, because it's sine square, you're supposed to square the whole thing. Right, guys? All right, so now we're just expanding the bracket. So you get here 1 plus 2 times e to the power a power minus a square divide by the square of 2, this power 2, you get the denominator here, that can be 2 square, which is 4. All right, guys, so then you take the common denominator now, so you get here 4 plus I could have simplified here, right? We could simplify 2 and 4, 2 times 1, 2 times 2. All right, guys, so I simplified this a little bit, and then I have here 1 plus, okay, you can expand the bracket, e to the power 2a minus 2 e to the power a e to the power minus a, right, guys? And then plus e to the power minus 2a. So this is just expanding the bracket. And then you have this fraction divided by 2. So time to go for the common denominator. So it's going to be 2, okay, because 2 plus you get here e to the power 2a. You know that this guy becomes 1, right? E to the power 0. When you add the powers, that's 1. So you get here minus 2 plus e to the power negative 2a, whole thing divided by 2. Right, guys? And you can see the plus 2 and minus 2 can cancel out. And you're remaining with e to the power 2a plus e to the power minus 2a divided by 2. All right, guys. So now Is this the formula for cos 2a? So you do recall, right? So cos x was ex plus e minus x divided by 2. So if it is cos 2x or cos 2a, replace x by 2a, right, guys? E to the power 2a plus e to the power minus 2a divided by 2. All right, guys. Okay. So you can see that we've got the show that here, right? So you can see that this is actually cos 2a. So we got the show that. So you can see that that we can easily prove it, right? So we get the proof. But now, how does it work? In the sense, how do you, maybe look at the trigonometric equation or the trigonometric identity directly and convert it to hyperbolic directly? All right, guys, because you can see doing these proofs one by one, it's going to be very time consuming. So we need a technique or we need a method to take our trigonometric identity and immediately convert it to the respective trigonometric identity, right? So we need a method because you know that you have many other trigonometric identities, right? So it's not just cos 2a, it's not just this, right? So you have many other equations for cos 2a. Cos 2a is also cos square a minus sine square a. Cos 2a can also be written as 2 cos square a minus 1. Now my question is, okay, I want to convert these also to the respective hyperbolic. So I want to get another pair of equations for cos 2a. So how do these terms, how are they going to generate? We know that they're going to look mostly similar, but we know there is a problem with the sign because you saw now we worked with two questions and there were some sign differences, right, guys? Okay, so this is where we are going to introduce you a new rule called the Osborne's rule. Okay, so let's go through that. Okay, so remember now, whatever about this part that we are going to discuss is entirely about converting a trigonometric identity into a corresponding hyperbolic identity. Okay, so you're not supposed to do this anywhere else, only when you're going to do a direct conversion from trigonometric to hyperbolic. Okay, so that's where you're going to use this particular rule. Okay, so given a trigonometric identity, it is generally possible to write down the corresponding hyperbolic identity using what is known as Osborne's rule. Okay, so basically they are telling you how to do the conversion from trigonometric to hyperbolic. So they say here replace the cos. Now you know cos is trigonometric, right? So replace cos by cos. So really very straightforward. So whenever you have a cos function, cos can directly be replaced by cos. Okay, so trigonometric cos is directly replaced by cos. And then they say replace sine by sine. So sine is your trigonometric part, sine is hyperbolic. So they tell you whenever you see a sine, just directly replace it with sine. Okay, that's quite simple, right? However, okay, there's one catch here. Okay, replace any product or any implied product of two sign terms. This is very important. Replace any product or implied product of two sign terms. Implied product means the sense sometimes you'll have the product hidden. Okay, so I'll show you these implied products also. Okay, where you don't immediately see there's a product of sign, but it is inside. Okay, so I'll show an example for this later. So replace any product or implied product of two sign terms by minus the product of two sign terms. Okay, so what are they saying here? They're asking you to replace if you have a product of two sign terms. Okay, when you make it, now sign becomes shine, right? Immediately. But when you have a product of two sign terms, the product of the two shine terms are gonna have a negative sign. Okay, so there are some examples here. So let's for example, guys, you can see here the conversion. So look at this conversion. Here you can see sine A, sine B. This is trigonometric. So when you convert it to hyperbolic, okay, sine A immediately becomes sine A. Sine B immediately becomes sine B. However, you can see you have a product of sine. So that's why you get a negative sign out there. Can you see? Trigonometric to hyperbolic. Whenever you see your trigonometric function has a product of sine, then when you convert to hyperbolic, okay, so you sine A becomes sine A, sine B becomes shine B, and you can see there's an extra negative sign outside. Do you see? So what if you have, let me give you some more examples. So what if you have cos A sine B? How does this convert? So in this case, you don't see any product of signs, right? So you can immediately convert. So cos becomes cos A, sin B becomes sin B. So it's a very straightforward conversion because in this case, you don't have a product of sign. Okay, guys, if you don't have product of sign, immediately you can go for the conversion. Okay. So let me show you an implied product. So maybe something like tan A, tan B. Okay, so I want to convert this to the respective hyperbolic identity. So how does that work? Now, guys, we know tan is actually what? We know tan is sine over cos, right? Tan B, sine B over cos B. So guys, over here, do you see something? So you can see here inside the tan, you have the sine function, right? And you can see when you take the product of tan A, tan B, you're actually, you're actually taking a product of two sine terms, isn't it? You're taking the product of two sine terms, which means you know that when you convert, it's going to be sine A over cos A. This is going to be sine B over cos B. But guys, you have a product of two sine terms, which means that you're generating a negative sign by Osborne's rule. Okay, so you need to have a negative sign here, which means the answer is going to be minus, it's going to be tanh A, tanh B. You can directly go for the conversion. This was just an extra step, okay, to show you the implied product of the sign. But you could go from tan A, tan B, this directly. So remember, if in other words, if you have a product of two tan terms also, you're actually going to get a negative sign because the inside the tan you have a sign. But remember, it needs to be a product of two of them. Okay, needs to be a product of two of them. All right, guys. So then let's do another one. Conversion. So you know this guy, right? Cos square A plus sine square A equals to 1. This is our basic trigonometric identity, right? In P2, the very first trigonometric identity we learned. Cos square A plus sine square A equals to 1. So how does this convert to hyperbolic? So guys, it's very straightforward now. Can you see? So you have cos, you know, you don't have any problems with cos, right? Cos can directly be converted even if you have products of cos, you know, cos square A is cos A into cos A. But that won't become, that does not give you any trouble. So cos becomes cos and directly cos square A. So no problem. All right, guys. And then here you have sine square A. You know, sine square is sine A into another sine A, which is a product of two sine terms, right, guys? It's sine A times sine A. So it's a product of two sine terms. So according to Osborne's rule, when you're doing the conversion, the product of two sine terms, when you convert, it becomes the negative product of the two sine terms, right? So you need to put a negative sign in front, and this is going to be sine square A equals to 1. I think you saw the proof of this, right, guys? So the proof of this equation is what we did on the previous page, right? So cos square A minus sine square is what actually becomes equal to 1. So the proof of this is what we did over here. All right, guys. So can you see that this is what you can see that you don't need to do hard proofs, but you can actually take a trigonometric equation and convert it to hyperbolic straight away. All right, guys. All right, guys. So I will also discuss three main examples. Okay, so these are some of the most important conversions you need to do. So basically, working with double angle rule. So here I have written down the three double angle rules when it comes concerning cos of 2A. So these are the three main rules you learn in P3, right? So cos 2A is cos square A minus sine square A, and 2 cos square A minus 1, and 1 minus 2 sine square A. So how do you convert this to hyperbolic directly? So it's really simple now, right? According with using Osborne's rule. So you have here cos 2A, okay, is equal to, you have here a product of cos. Cos square A is a product of cos. So you know that there's no problem here. So that's immediately going to be cos square A. And over here, guys, you have a product of sine. So if you have a product of sine, you know it's going to, when you convert to hyperbolic, it's going to generate a negative sign. And that negative sign with this, the other negative sign over here in front together, it's going to give you a positive sine square A. All right, guys, can you see? So this is the equation for cos 2A. The second equation for cos 2a is gonna be, you can see here you have to cos square a product of cos, but you know you don't have any issues with that. So it's gonna be 2 cos square a minus 1. So basically there's no, you don't see much of a difference here. Okay, so there's not much of a difference. It's almost the same. Okay, so this guy, because in this equation there was no implied product or there was no product of sign. Okay, the last one, cos 2a is going to be cos 2a 1. The one you wrote it down, so minus 2 sine square. So guys, here you can clearly see you have a product of sine. If there's a product of sine, when you convert it, it's going to give you a negative product of the hyperbolic sign, right? So that negative with this negative is going to give you plus 2 sine square a. All right, guys. So these are some direct conversions that you need to do, especially in the next few chapters where you're going to learn differentiation, integration. So you're going to work a lot with these hyperbolic functions, and you need to be able to do these conversions directly. Okay, so and work with them. So these are the equations that you'll need to work with in the next few chapters. Okay, so these are really important. And then we'll also write the double angle of sine 2a. So you recall this, right? Sine 2a was 2 sine a cos a, right, guys? Do you recall? So over here, let's convert it to the corresponding hyperbolic, because we will be using this frequently in the next few chapters. So sine 2a is going to be sine 2a. So guys, here do we have any issues? Do we have any product of two sine terms? You can see you have sine and cos. So you don't have a product of two sine terms specifically. So then it's going to be 2 sine a cos a. So you don't have a negative sign generated. So you can directly convert here. So that's no problem. All right, guys. So these are some really important rules that you will definitely need to follow, right? So, and the other main rule was this guy. Cos square a plus sine square a equal 1 converted to all right, guys. So you can see I've written down some of the main rules that you'll be working with here, right? It's especially in our next few chapters. You'll be using all these quite frequently. So you need to know all of them, right? So either you must remember these or you can remember the trigonometric and quickly do the conversion. Okay, guys? All right, guys, so I'll move on to exercise 1D. So I'll just choose a few questions. Okay, so question number 1, they say prove the following identities using the definitions of sin x and cos x. Okay, so you have to use the definition and you have to get the answer. Okay, so this is quite similar to what we did over here, right, guys? So these were where we used the definitions and simplified and got the answer. So basically that's the idea. Okay, so I'll just do a few questions. So maybe B and D. So part D, you have to show cos A minus B is equivalent to cos A cos B minus sin A sin B. All right, so let's work on this. Cos A. Okay, so let's directly substitute. Cos A is gonna be e to the power A plus e to the power minus A divided by 2. Right, guys? Cos B e to the power B plus e to the power minus B divided by 2. Minus sin A e to the power A minus e to the power minus a divided by 2, right, guys? And then sin b e to the power b minus e to the power minus b divided by 2. Okay, so these are the products. So now you need to actually multiply them out. Okay, you need to multiply them out. So there are two terms here. So you have to multiply them together and multiply them together. And then finally we can go for the subtraction. Okay. All right. So here you have common denominator is 4, where you multiply the denominators. So now let's multiply the numerators. Okay, so e to the power a into e to the power b is e to the power a plus b, right, guys? I'm gonna write it immediately. Okay, because you don't need to waste steps. So e to the power a multiplied by e to the power b. You know, when you're multiplying, the indices are added. So e to the power a plus b. The next guy, e to the power a into e to the power minus b is gonna be e to the power a minus b. Right, guys? The other guy, uh, e to the power minus a into e to the power b is e to the power b minus a. And the last guy, e to the power minus a multiplied by e to the power minus b is e to the power minus a minus b. All right, guys, divide by 4. And on the other side, we have minus. So 2 times 2 is 4. Let's open the bracket. E to the power a into e to the power b. That's e to the power a plus b. The power a. So it's going to be, guys, over here, you multiply e to the power a with negative e to the power minus b. So it's a plus into minus is a minus. E to the power a minus b. Right, guys? A into minus b. The powers add a minus b. The next guy, you multiply minus e to the power minus a with e to the power b. So end of the day, it's a negative e to the power b minus a. I hope you guys are following me, right? And the last one, minus e to the power minus a with minus e to the power minus b. So minus into minus is a plus e to the power minus a minus b. All right, guys, I hope you understood how I expanded the bracket. It's really simple, just normal binomial expansion, okay? And basically the powers of e are added, okay? And then it's time to add them all together. I think if you can see terms that cancel out, let's cancel them out, right? So instead of wasting time and writing steps again. So I can see here, 4 is a common denominator. So therefore, you can immediately compare your numerator. Okay, so e to the power a plus b, and there's a e to the power a plus b with a negative sign. So I know that these two terms cancel out. All right, guys. And we have e to the power minus a minus b. And here you have with the negative sign, when it comes in, you have minus e to the power minus a minus b. So you can see you have the same term, positive and negative. The powers need to be equal in order to compare them. E to the power minus a minus b is the term I'm comparing. Here I have plus 1 of it. Here I have minus 1 of it because of this minus sign from outside. This is minus 1 of it, right? So you have equal quantities of the same person, which cancels out. All right, guys. So I think we are remaining with the rest of the thing is the remainder. So we can add them up. They don't cancel out, right? E to the power a minus b plus e to the power b minus a. On over here, guys, you have minus minus. So that's going to be plus e to the power a minus b. And here minus minus, that's plus e to the power b minus a. All right. Divide by 4. And then you can simplify this a little bit further by taking terms that are by adding the like terms. So you have e to the power a minus b, e to the power a minus b. That's going to be twice of the same guy, right? And this is going to be e to the power b minus a, e to the power b minus b. That's going to be plus twice of e to the power b minus a. Divide by 4. So you can simplify this a little bit further by taking a factor of 2 out, and you can cancel out 2, right? Everyone has 2 in common, so you can immediately remove it. E to the power a minus b plus e to the power b minus a divide by 2. All right, guys. I could rewrite the same thing as e to the power a minus b plus e to the power. You can take a negative sign out and write a minus b, right, guys? Can you see? Because b minus a is the exact same as saying negative of a minus b. You expand with the negative sign and you get this, right? It's the exact same thing. And I think you can see it works out, right, guys? Because cosh a minus b. We know cosh x is ex plus e minus x divided by 2. So cosh a minus b. You replace x by a minus b, right, guys? E to the power minus. You can see we have an exact copy of cosh a minus b. It's supposed to look like this, and this is exactly what we have over here. So I have generated cosh a minus b. And thereby we got the proof, right? So we have our answer. We got the answer for part B. Okay, guys? So it's just a long simplification, but it's really simple. Okay. So I'll do one more question. Shine A minus shine B. Equals to 2 shine A minus B. over 2 cosh A plus B over 2. All right, guys. So we need to work on this and we need to get the show that, right? So guys, you need to choose which side to start from, right? So I think I'm going to choose with this because I can see there are larger, the angles are more complex. So we'll start with this side, looks simple, right? So we start from the complex side and let's go to the simple side, okay? So 2 sine A minus B over 2. So 2, sine X is EX. So here X is A minus B over 2 EX minus e to the power minus X. Divide by 2. Can you see, guys? So you can see the way I've placed brackets and I've done everything, right? So EX, basically the EX conversion, EX definition. I've replaced the X by A minus B over 2. Okay, so EX minus E minus X divided by 2. You can see X is replaced by A minus B over 2, right? And then you can even, you can see the 2 immediately cancels out. And then cosh A plus B over 2, how does that work? And so that's going to be cosh A plus B is going to be EX. X is A plus B over 2, right, guys? EX plus e to the power minus Z. Okay, divide by 2. All right, guys. Okay, so this is what you have. So now we need to expand the bracket, like basically do binomial expansion. Okay, so in the numerator, I have this. I'm going to multiply. So it can be binomial expansion. E to the power A minus B over 2, you multiply with e to the power A plus B over 2. So what do you get here, guys? You know that when you multiply, the powers add. Okay, I wrote it immediately. Said, okay, I multiplied e to the power A minus B over 2 with e to the power A plus B over 2. And that's why the powers are adding. Okay. The next guy, when you multiply, I think you can see we don't have a sign problem. It's plus E A minus B over 2 with plus E minus A minus B over 2. So it's going to be plus E and you add the powers. A minus B over 2, you're adding with minus A plus B over 2. Right, guys? Can you see? So I multiplied these two. Okay, next term. You multiply. Okay, so now it's important. You have a negative sign here and you multiply this. So minus into plus is a minus. And e to the power, add the powers here, minus A plus B over 2 minus A minus B over 2. You add with A plus B over 2. Okay, guys, so that's these two terms. Okay, these two terms. And then finally, the last two terms, minus with this plus, right, guys? Are you with me? You multiply these two terms. Okay, this guy with this guy. That's the last term. So minus into plus is a minus. And you have e to the power, add the, you can add the powers, A minus B over 2. Here you have to add with minus A plus B over 2. Divide by the common denominator. I think you can see in the new denominator, you just have a 2. Okay. You don't take common denominators here. It's all a product, right? So these are products. So you just immediately multiply the denominators. It's 1 times 2. It's just a 2. Okay. Okay, now time to simplify. Okay, so what do you get here, guys? E to the power A minus B divided by 2 and A plus B divided by 2. So you can immediately add them out, right? A plus B over 2, sorry, A minus B over 2 and A plus B over 2. You can immediately do this, guys. This is really easy. So you can see here common denominator is 2, B cancels. So it's going to be 2A over 2, which is A. All right, guys. So you get here e to the power A and that's it. E to the power A. And the other guy, so you need to add them out. A minus B over 2 plus into minus is minus A plus B over 2. When you add them out, guys, what do you get here? Plus A minus A cancels out. Minus B is going to be minus 2B over 2, which is minus B. So you get here e to the power minus B. All right, guys? E to the power minus B. So you need to do this simplification. The next person, negative. We have a negative sign here. That negative comes here. So you have to add the powers. What are the powers? Minus A minus B over 2 with A plus B over 2. So when you add them out, you have minus A plus B and a plus b. So common denominator is 2. The a cancels. You get b plus b. That's 2b divided by 2. 2b divided by 2 is b. So the third term, the power is going to be e to the power positive b. All right, guys. Do you agree? Okay. And then the next one. So the next one is going to be, you can see there's already a negative sign out front. So write the negative sign. Let's add the powers. Minus a minus b over 2. You add with plus into minus is minus a plus b over 2. Common denominator is 2, right, guys? So it's going to be minus a plus b. So it's going to be minus a minus b. Can you see, guys? Minus a plus b. Here, minus a minus b. So you can see here the b cancels out. Minus a minus is minus 2a divided by 2. That's going to be minus a. All right, guys. Divide by 2. This is what you get. Okay. And now it's time to separate them out. So separate them. So you have here e to the power a minus e to the power negative a divide by 2 plus e to the power negative b minus e to the power b divide by 2. Can you see, guys? I separated the a terms and the b terms. All right. I think you can see the moment you look at this, you know what this is, right, guys? Because you know you're supposed to remember the definitions of shine and cosh. So it's shine x definition is ex minus e to the power minus x divided by 2. So you can see you have the definition of shine a here perfectly, right? Over here, we need to do a little bit of work, right? Because you can see the things are a little changed. So take a negative sign out. Take a negative sign out of these two. Okay, now you know it comes from the numbers in front, right? So you take a negative sign out, and it's gonna be positive e to the power b, and it's gonna be negative e to the power negative b. Right, guys? I just took a minus one out. Okay, you know there's just a one here. Take a minus one out, and this is gonna be positive e to the power b. This is gonna be the here it's gonna be negative e to the power minus b. So guys, we have everything we need here, right? So you know that this is shining minus, and you know this is shine b. Right, so by our definitions of shine and cost, shine and shine definition. Okay, so you have it perfectly. All right, guys. All right, guys. So we'll do question number 2 as well, like a quick review of it. So I think it's really easy, right? They ask you use Osborne's rule to write down the hyperbolic identities corresponding to the following trigonometric identities. So basically converting to trigonometric identities to hyperbolic. Okay, so it's very straightforward. You remember you convert sine to shine, cos to cosh. The only place where you have to be concerned is if there is a product of sign. If there's a product of sign, you know you need to put a negative sign. Okay, so that's it. So here you have sine a minus b equals sine a cos b minus cos a sine b. So converting this to hyperbolic, and we get shine. Shine a minus b, right, guys, equals to shine a cosh b. Now you can see we don't have any product of sign terms, right? So you can immediately convert. It's going to be shine a cosh b minus cosh a shine b. The conversion is very straightforward here, right? Because you don't have any product of sign terms. Okay, guys, so that's the first question. Part B, you have sine 3a equals 3 sine a minus 4 sine cube a. Okay, guys, so here you have to be a little bit cautious, right? So sine 3a immediately becomes shine 3a because you just have a sine term on its own. 3 sine a is also fine. It becomes 3 shine a because you have the sine term on its own. It immediately becomes to the corresponding hyperbolic. That's fine. But here, guys, you have shine cube a. You know, shine cube a is actually sine cube a is sine times, you know, sine multiplied by sine multiplied by sine. So you know that when you're converting to hyperbolic, you know, sine becomes shine. That's fine. But when you have a product of two of them, you know, it's going to give a negative sign outside, right? So these two together, okay, that's going to produce a negative sign. So negative sign with this negative sign gives positive 4, and you can see here sine A, shine A. Here, this guy is on its own. This sine A is on its own. So, you know, on its own, it can't produce a negative sign. You had another sine A here, then that produces a negative sign. Okay. So this sine A is on its own. Only this particular pair can produce a negative sign, which went out here to make this negative positive. Okay. And then you have here shine A, shine A, shine. That's shine cube. All right, guys. Okay, so that is that's the answer for part B, right? All right, guys. So I think I'll just quickly say the answer here, right? So cos A becomes cos A in part C. Cos B becomes cos B. This is going to be two. So you have a product of cos terms here, guys. So you can disregard the angle, whatever it is here. You have product of two cos and there's another cos. So product of cos doesn't give us any problem. So you have two cos of this angle and cos of this angle. So it's a direct conversion. There's no problem here. Okay. But this guy over here, the next guy, I think you can see there's a tan. And I told you when there's a tan, it means there is a implied sign product because inside of tan, you have a product, you have a sign, right? And since it's tan square, you have two tan. So tan A into tan A, which means inside you have a product of sign. So over here, when you do the conversion, this is going to be cos 2A. 1 minus tan square becomes 1 plus tan square. Right, guys? Do you get it? I think I showed you why the tan product in my example, right? This is going to be 1 minus tan square. The signs are going to change because you have a product of sign here. And then when you take the product, when you convert to hyperbolic, it's going to give a negative sign. So the signs are going to change. Okay. And over here, guys, the last one, part E. Cos 2A equals cos to the power of 4A minus sine to the power of 4A. So how does this work, guys? When you convert, it's going to be cos 2A. Cos to the power of 4A is actually directly cos to the power of 4A. You know, cos doesn't have any problems, regardless how many uh, products you have, right? It's directly going to come. But what about sine to the power of 4A? Sine to the power of 4A is, you know, it's sine square into another sine square, right, guys? All right, guys. So here you have product of sine square into another sine square. So you know each sine square is gonna when you convert to hyperbolic, it's gonna give you a negative sine square, and this one gives another negative sine square. And so when you multiply it, guys, minus minus is gonna be a plus, right? So it's gonna be a plus here. But remember, outside of this entire thing, there's another negative sign here. Can you see? So leave that negative sign. Okay, and here you multiply minus sine square with minus sine square. It's going to be plus sine square. Right, guys, can you see? So it basically doesn't do much of a difference because you have a sine to the power of 4. The sine square, when you break it into two sections, each section produces a negative and another negative. So each negative, it multiplies with each other to give a positive. So end of the day, this term on its own converts directly to sine to the power of 4a. Okay, sine to the power of 4a. And this minus mark is going to stay out front, right? Because it's not being affected. There's no negative sign coming out of the entire expression. The entire expression is a positive. Okay. All right. All right, guys. So I'll just select a few questions here. I think we're almost done with the chapter now. So we'll do third one, part A. They say given that cos x is equal to 2, find the exact values of sin x. So guys, these are basically stuff you've done in P3 and you're just supposed to use those rules here, but you have now go with the corresponding hyperbolic rule. So how do you get the value of sin x? So you can go with the identity, right guys? So I think over here I gave you all the main identities, right? So you can see here, this is the one we can use here. Cos square x minus sin square x is equal to 2, right guys? Cos x is 2, so cos square x is going to be 4 minus sine square x is equal to 2. So you have 4 minus 2. 2 equals to sine square x, which gives you sine x is equal to square root of 2. And you know, you get plus or minus. Right, guys? Yeah, sorry guys, over here. Okay, so I've done a mistake, right? So cos square x minus sine square x is equal to 1, right? Okay, this is equal to 1. Okay, sorry about that. So you get here, I mean, that's your identity, right? Cos square minus sine square equal 1 is our identity. Okay, so that's going to give you 4 minus 1, that's 3, and you get sine x is equal to square root of 3, plus or minus. And you know, according to the sine x graph now, it's important that you're working, when you're working with these kinds of expression, that you remember the graphs of sine, cos, tan, because you know their range and you know what values are possible and not possible. So you know, according to sine x graph, right, that both these values are possible because this is the shape of the sine x graph, and you know sine x is possible to be equal to positive root 3 and negative root 3. Okay, so that will be helpful to you guys. Okay, and then find the value of tan x. So how do you find the value of tan x? So tan x is can be written as sine x over cos x, right, guys? So you can see we have two possibilities of sine x. Both these values are possible. So you can get two possible values of tan x. So you can get here tan x. So when sine x is positive root 3, cos x is 2, or you can get tan x. Sine x is negative root 3 over 2. Even according to tan graph, you know, tan graph, you know, this is possible, right? If you recall the shape of the tan graph, we've done these things previously. All the graphs were very clearly explained, right, guys? You can go through this. You can see that both these values are, it's possible to get both the values. And then finally, cos 2x. So guys, in order to get cos 2x, I think I generated all the three rules here, right, for cos 2x. Okay, so you can use any one of these three identities to help you. Okay, so any one of them is okay. So I think I'll go with the cos one because I know cos x is equal to 2 and that's given to me, right? So I'm not going to be using any values that I've found. Okay, and it only has one value there. So cos 2x, I'm going to go with the second expression, 2 cos square x minus 1. Right, guys? So this is what we derived earlier, 2 cos square x minus 1. Substitute the value, we know cos x is 2. So it's going to be 2 into 2 square is 4 minus 1. 2 times 4, 8 minus 1, which is 7. So cos 2x is equal to 7. All right, guys? All right, guys, so I'll move on to question number 5, and we'll just do a few questions that I feel that you need help. Okay, so to give you a heads up. Okay, so I'll do the first question. You have 3 sine x plus 4 cos x equals 4. So guys, it's important you know how to solve these kinds of equations because you'll be definitely tested in the exam. Okay, and they say to give your answer as natural logarithms. Okay, so let's see how it's done. Now, guys, over here, when you look at 3 sine x plus 4 cos x equals 4, so you can see immediately that, you know, you can't use any identities because any identities you have work for sine square, cos square, or for double angle. Right, so this is very simple sine x and cos x, so that's not going to work. So in this kind of a situation, it's always better or it's always easy to go with the definition. So let's go with the definition. What do you get? 3 times sine x is ex minus e minus x divided by 2, right, guys? And here 4 times cos x is ex plus e minus x divided by 2 is equal to 4, right, guys? So you substitute the values by using your definition for sine x and cos x. And now it's just time to simplify. So you get here 3 times ex minus e minus x plus 4 times ex plus e minus x. And I think you can see 2 is a common denominator, right? So I'm not going to cut this 2 and 4 here. Instead, I'll take 2 as a common denominator, okay? And this is equal to 4. So it makes our life easier, right, guys? Expanding bracket, you get 3ex minus 3e minus x. Here you get 4ex plus 4e minus x, right, guys? And you can take 2 to the other side. 2 times 4 is 8. Add the like terms. 3ex, 4ex is 7ex. And when you add the other pair, minus 3e minus x plus 4e minus x, that's going to give you plus e minus x, right, guys? Minus 3 plus 4 plus 1 equals to 8. So if you look at it carefully, you should be able to see that this is actually quadratic. Okay, why? So you have e to the power positive x and e to the power negative x. In such a situation, you can take your entire equation, multiply it with e to the power x. Okay, so what do you get then? And you end up getting 7 e to the power 2x, the powers sum, right? Ex into ex, the powers add, and you get e to the power 2x. Here you get e minus x, e plus x, you know it's going to be e to the power 0, right? And this is 8 e to the power x. This is e to the power 0, and you know it's equal to 1. So you end up getting 7 e to the power 2x plus 1 equals 8 e to the power x. Taking everything to one side, 7 e to the power 2x minus 8 e to the power x plus 1 equals to 0. All right, guys. So this is your, you can see it's a quadratic equation. You can clearly see it's a quadratic equation. So you can either factorize it, complete the square, or go for the formula. So I think you can easily factorize this, right? So you can use the help of your calculator to quickly factorize, or you can do it from your head. This is 7 times 1. Right, guys? And this is going to be minus 1 times plus 1, minus 1 times minus 1. Right, guys? So I think in this case, it's possible to factorize, right? Yeah. So you can use the help of a calculator or any technique. Okay. So to factorize, these are basically P1 techniques. Simply like 7a square minus 8a plus 1, and you just break it into factors: 7a minus 1, a minus 1. Okay, that's what I did. A is simply the e to the power x, the lower power, right? Is what you take inside the bracket. I think you guys should be able to understand it, right? Because I think you're doing the. I think this stage, I believe you should be able to do these kinds of things easily, right? And then yeah, so you make them equal to 0 on its own. So you get here 7e to the power x equals 1. E to the power x is 1 over 7. Here you get e to the power x is 1. So guys, you need to make x a subject, and I think they've told you in the question to give your answer as natural logarithm. Okay, so it needs to be natural logarithm. So natural logarithm, you know what you should do here, take the natural log of both the side. Okay, log base e is the natural logarithm. So let's take the natural log of both the side. And you know what you end up getting here, right? The x comes front, and natural log of e is 1. And here you get log of 1 over 7, natural log of 1 over 7. Here you get ex equals 1, so you apply the natural log to both the sides. So you get x times ln e, and here you get natural log of 1. Guys, you should know natural log or logarithm. In logarithm to any base of 1 is actually going to be 0. Okay, so these are actually, I mean, you can type this in the cal. Of course, natural log of 1 over 7 should give you a decimal. Okay, so we are not going to go for the decimal. They ask the exact natural log. Here, guys, the thing is when it comes to natural log of 1 or basically any logarithm for any base, if you take the logarithm of 1 with any base, it's always going to be 0. These are some properties of logarithms you've learned in P3, right? Okay, so these are your two answers, okay, for this particular question. Okay, guys, so you can see that the other questions over here, if you have just shine and cosh, the methods are actually going to be very similar. Okay, so you can try them out on your own. So I'll go with a different one. So probably maybe something like part E, because you can see you involve working with double angles. So how do you work with a question like this? Now, guys, you know cosh 2x, you have 3 expressions, right? Because we have 3 expressions for the double angle of cosh. So which one do I use? I can see on the other side, I have just a shine x. So basically, the best thing to do here is, guys, for the cosh 2x, I believe I'll work with the one with the shine function. Can you see? So there are 3 definitions or 3 equations for cosh. But since my equation here involves a shine, I'll work with the person that has a shine square here. So cosh 2x is 1 plus 2 shine square x. That's the expression I'll be using because that's going to make my life easier. So 1 plus 2 shine square x. All right, guys, and here minus 5 shine x equals 13. All right, guys. So you simply substitute the value, and now you can see. Okay. So now my suggestion to you is now just because we did the first question in this way, where you substitute the definitions for shine x and cosh x, do you really have to do the exact same thing here, where you replace shine x by its definition, ex minus e minus x over 2? Actually, you can see you don't need to do that here, right? Why? Because you can see that you have that at this point, you actually have a quadratic equation with shine. You already have a quadratic equation with shine, and you can solve for it, right? So you don't need to go through these kinds of simplifications, definition simplification, because I mean, it's not necessary, right, guys? All right, guys. So you already have a quadratic equation with shine, so you don't need to go for the definitions. Okay. In the previous question, you really could not simplify it any further, right? Because you did not see any direct quadratic equation at the beginning, these questions. Okay. But here you see a quadratic expression. So let's go with it. So you have here 2 shine square x minus 5 shine x, and you have here 1 minus 13, that's minus 12 equals 0. All right, guys. So now you can try to, it's a quadratic equation with shine. So you can use your calculator, or you can try to, factorize, right? So you factorize this well, right? In the calculator, if you give your ABC values, you get x equals minus 3 over 2 and x equals 4, right? So here x is shine x. So x equals 3 over 2. That's going to be 2 shine x minus 3. X equals minus 3 over the 2 shine x plus 3. And this guy is going to be x equals 4. So it's going to be shine x equals, so shine x minus 4. All right, guys. So you can factorize in whatever the method that you use. Okay. So you guys use method techniques you use in P1. Go for it. Okay. So make sure you show the factors though. Okay. Yeah, show your methods. And then you write here 2 shine x plus 3 equals to 0, or shine x equals shine x minus 4 equals 0. So you get here shine x equals minus 3 over 2, or you get here shine x equals to 4. All right. And now, guys, how do you get the value of the x? Because you're supposed to get the x value. So now, again, do you need to go for the definition value x minus e minus x over 2? No, right, guys? You don't need to go for that. Why? Because here you can make x the subject. X is r shine. R shine. Do you recall r shine, the inverse function? And here x is r shine 4, right? And guys, I think if you recall on the previous section, we learned the expressions, right? We derived and we proved the expressions for r shine x, r cos, and r tan, right, guys? So here you can see r shine x. We already have an expression with the natural logarithm. So all these proofs were done. Okay, so r shine x is natural log of x plus root x square plus 1. Okay, so that's r shine x. R shine x is natural log of x plus root x square plus 1. All right, guys. Okay, so let's just time to substitute those values, right? Simply substitute. So x equals natural log of, now your x value is minus 3 over 2, right? So minus 3 over 2 plus square root of minus 3 over 2 square is 9 over 4 plus 1. Okay, that's one answer. Or the other answer is natural log of x is 4 plus root 4 square, that's 16 plus 1. Right, guys? So you get here, let's simplify natural log of minus 3 over 2. You get here 9. So it's going to be root 13 over 2, right, guys? And this is going to be natural log of 4 plus root 17. Yeah, those are your two answers. Okay, so you can take it to maybe a common denominator. Okay, guys, so these are the answers. So you can see how it works out, right? So every question you can see, if it is possible to make a quadratic expression at the very beginning, then go for it. Okay. because in these questions, even part if you can see that you can use sine square x, and when you have cos x, these are basic trigonometric stuff, right? P3. You can use convert sine square to cos square by using the cos square minus sine square equal 1 inequality, and replace the sine square x in terms of cos square x, and you get a quadratic equation completely with cos, and you can solve it and get the answers, right, guys? So I think these are all pretty much straightforward, and you can use techniques that you've learned in uh, the techniques you learn in P3. Okay, and it should help you out. Okay, guys. So I think we're done with the lesson. So I think I've taught you everything that you require. So you should be able to do papers, and we will be doing discussions with papers soon. Okay, guys. All right.